Hope you have gone through the previous tutorials covering LR Parsers and computation of LR0 automation. So in this tutorial, we are going to have a discussion on construction of LR parsing tables. First, we will have a look at on this different types of LR parsing. So we can classify these LR parsers as symbol LR parsers or SLR, canonical LR parsers or CLR, and a look ahead LR parsers or LALR. Now we can see the model of an LR parser over here. There is an input buffer, there is a stack, there is an LR parsing program, and we have an LR parsing table. This different type of parsers, all of them have the same structure, only difference comes in this construction of parsing table. When LR parsing program is same for all, only difference comes in this construction of this LR parsing table. So in the case of SLR, it will be constructed with SLR method. In the case of CLR, CLR or LR1 method. And in the case of LALR, it is constructed with LALR1 method. So let us see in detail what are the different parts of a parser. The first one is an input buffer. So we have seen input buffers in different scenarios. It's used for storing the input and the end of the input is marked with a dollar symbol. Okay. And next we have a stack. The stack is used for storing symbols like grammar symbols as well as states. The S symbol it indicates the state symbols and capital X indicates the grammar symbols. Okay, and SM represents the topmost symbol in the stack. Okay, so hope you are clear with the structure. Then the parser table, it consists of two parts, action part as well as go to part. Now we will see in detail how to construct this action and go to in the table. Okay, so just remind that these are the parts and only difference comes in the table. Now before going into detail, we will just have a look at what are the different characteristics of this different type of parsers. Now this SLR, it works on smallest class of grammar. LR1 works on complete set of LR grammar, and LALR1 it works on the intermediate size of the grammar. And in the case of SLR, the number of states will be very less and hence the passing table will be very small. In the case of LR1, number of states will be more, hence it generates large table. In the case of LLR1, number of states is small or very few and hence the table will also be small. And in the case of SLR1, it is simple and fast construction. In the case of LR1 or CLR, it is slow construction, and LALR1, it is simple and fast construction. And in the terms of power, SLR is least powerful, CLR is most powerful, and LLR is intermediate in power. Hence, the cost for SLR is less expensive. A CLR is most expensive as it is most powerful, and in the case of LLR, it is intermediate in cost. So these are the different characteristics of different type of parsers. Now we will see these structures in detail. So first is our input buffer. As I have discussed, the parsing program reads characters from an input buffer one at a time. And in the case of stack, it uses a stack to store strings of the form S0, X1, etc. to SM, where SM is on top of the stack and XI is a grammar symbol and SI is a state. And this is a point that you have to keep in mind. Each state symbol summarizes the information contained in the stack below it. That means if it is in state SM, it means that it has gone through all the actions till SM. Okay, that is what it's said here. Each state symbol summarizes the information contained in the stack below it. Now, now, the combination of state symbol on the stack top and current input symbol are used to index the parsing table and determine the shift reduce parsing action. Now, this parsing table it consists of two parts: action and go to. If it comes to action part, there can be four chances. On other, either it can shift, either it can reduce, either it can accept, or it can report an error. So, how this parsing table is used is a topmost symbol of the stack and current input symbol is used for consulting the parsing table. Depending upon the result from parsing table, the appropriate action is performed. So we will first have a look on what are the parts of parsing table. It consists of two parts: parsing action function action and go to function go to. Okay. Now what this action consists of is this function takes an argument, a state I and a terminal A or dollar. Keep in mind, in case of action, it takes as argument a state I. So you know what is a state? Collection of items is consists of a state. So it takes as arguments a state I and a terminal A. Okay, only terminals are considered, and also dollar is also considered for constructing the action part. And the value of action of IA can have one of the following forms. Okay, so when we consult the action part, it can have one of the following forms. What are the? It can be shift J, where J is a state. Either it can shift to another state, reduce by a grammar production, A giving beta, or it can reduce by a production, or it can accept, or it can report an error. Now, second one is go to. As go to, it takes a state and grammar symbol as arguments and produces a state. Okay, and here you have to keep in mind that the grammar symbol will only be non-terminal symbols. Okay, we won't consider terminal symbols while constructing go to part. We will take the state as well as the non-terminal. Then the result will be another state. Okay. So now we will see how a parsing program works. So configuration of LR parser is a pair. Okay. The first pair is the stack component and the second pair is the input. Okay. Then how the next move of parser is determined? By reading AI, that is the current input symbol, and SM, that is the top of the stack, state on the top of the stack, and then consulting the parsing action table entry. Okay, with this SM and AI, it will consult the parsing table. Now, the configuration resulting after each of four types of moves are as follows. So, result will be one of the following. One, action SMAI if is equal to shift S. Okay, when we consult the parsing table with symbol SM and AI, the result can be shifted. Then what we should do is we should push this state in the stack. Okay, then SM, that is top of the stack, will become this state. Okay, so it executes a shift move entering the configuration this. Okay, so this SM now it will become S because since it is shift S, we have to push that S to SM. For example, if state was 0 and AI was ID, and when I consulted the passing table, if on I0 comma ID I have to give shift 4, then I have to shift to the state 4. So what I have to do is I have to push this state, that is the state 4, to the stack. So 4 will be on the stack top. That is the one step, or it can be one of the possibilities. It can perform a reduce action. Okay, so when we consult the state, the parsing table with the state SM and the terminal symbol AI, it can be reduce A giving beta. Then what we have to perform is we have to take the modulus of this beta. Okay, suppose the prediction is E giving ID, then ID is beta part and modulus of ID is 1. Okay, if it was E giving E plus T, modulus of beta is 3. Okay, E plus T consists of 3 elements, so modulus value become 3. So take modulus of beta and then we have to pop that much elements from the stack. Okay, so if in my example I am taking A as A giving ID, then what I have to do is take modulus of ID, then it is 1. Have to pop one stage from the stack top. Then what I have to do is I have to push this symbol into the stack. That is capital A will come on stack top. Then I should consult the parsing table with the state symbol and capital A. Then I will get another new state and have to push it. Okay, so we will see that in detail when on coming slides. And next action is it can be accept action, or other possibility is accept, that is parsing is completed. And another possibility is it can be an error. If the parsing table entry contain null value or there are no values in a particular column, it is considered as an error and calls for an error recovery routine. Now we'll see LR parsing algorithm. So input, as I have told, it is the input string W and LR parsing table with functions action and go to for a grammar G. Our output will be if W is in LG, a bottom-up parser for W will be created. Otherwise, an error indication will be given. So method, initially the parser has a 0 on its stack, that is the start state, and $$ is in the input buffer. Then parser executes the following program until an accept or error action is encountered. Now this is the algorithm. So let us see. Set IP to point to first symbol of $. Okay, we have input buffer with $. Set IP to point to first symbol of $. Then begin. Let S be the state on top of the stack. Okay, now the top of stack initially will be state 0. So let S be the state on top of a stack and A be the symbol pointed to IP. Okay, so now the stack top consists of the state S and input symbol is now what? A. Then what we have to do, we have to consult this parsing table. If action of SA equal to shift S dash, okay, we have shift S dash on the parsing table, then what we have to do, push A, then S dash on top of the stack. Okay, what we have to do, push A, then S dash on the top of the stack. Then advance IP to next input symbol. Okay, so the terminal that we have encountered as well as the shift, okay, state is pushed on the top of a stack and we are incrementing or advancing IP to next input symbol. So this is in the case of shift. Let us see what we have to do when we have a reduce action. So if action of SA equal to reduce, then begin pop modulus beta symbols of the stack. So I have explained already how we will calculate modulus beta. So pop that much symbols of the stack and let S dash be the state now on top of a stack. Suppose after popping ID, top of a stack consists of S4, then S dash is the S4. Okay, on top of the stack, what is the state now after popping, that we have to consider. Then what we have to do, push A, that is the LHS of this production that we have to push. Then again consult the parsing table with go to of S dash comma A, that is a current state on the top of a stack, and LHS of a production has to be considered for consulting the passing table. And we have to output the production A giving beta. So this action part with a reduce action is a little bit confusing, but it is simple when you think once again. What you have to do if there is a reduce A giving beta, first you have to take modulus of beta, then pop that much symbols of the stack. Then what you have to do, there will be a new state on the stack top, then you have to push this A onto the stack, then consult the table with S dash A on top of a stack, then you will get some value, either it can be shift or it can be again reduction, and what you have to do is output A giving beta. Now else, if action of is equal A equal to accept, then return, else report the error. So this is the LR parsing algorithm, and this will be followed for all the parsers. Now constructing SLR parsing tables. So that's a general algorithm. Now we will see how SLR parsing tables or simple LR parsing tables are constructed. Now, LR parser using SLR parsing table is called an SLR parser, and a grammar for which an SLR parser can be constructed is an SLR grammar. Now, how we can construct an SLR table? First, input is an augmented grammar G dash, and output is SLR parsing table functions action and go to for G. Now, this is the method. So number one, construct C. What is C? Canonical collection of LR items. Okay, that's what we have discussed in the last tutorial, how we can compute LR0 automation. So same, that's the first step we have to do. Then state I is constructed from II. Okay, that is if state 0 is constructed from I0. Then the passing action for state I are determined as follows. This is how we can write an action or go to in the passing table. If A giving alpha dot small a beta is in II and go to of II comma A equal to ij, then set action of IA to shift j. Here A must be a terminal. C. We have to check whether there is a production of this type in a set. Okay, if I have constructed I0, you have to check whether there is a production of the form A giving alpha dot A beta. In simple terms, we can say whether there is a terminal symbol after the dot. Check whether there are any productions with a terminal symbol after dot. Okay, then you have to check whether there is a go to action. Okay, from that II on A for the same terminal symbol, whether you have written a go to. Okay, then what you have to write, then set action of IA equal to shift A. Then you can write on that passing table action of that particular state I comma A, that is the terminal symbol, equal to shift J, that is to which state you are performing go to action. Then second is if A giving alpha dot, that is if there are no terminal symbols or there are no symbols, no, not at all terminal, if there is no symbols after dot, what you have to do, set action of IA to reduce A giving alpha. Okay, then what is A here? It is all terminal symbols in follow of A. That is, if there is a production in II of the form A giving alpha dot, that is dot is at the end, what you have to do is compute follow of capital A. Okay, then you will be getting a set of terminal symbols, right? Then write reduce A giving alpha to all that symbols. Okay, then the third condition is if S dash giving S dot is in II. Okay, there will be surely this production, right? If it is in II, then set action of I comma dollar to accept. Okay, write action of that particular state number comma dollar to accept. So if any conflicting actions are there, we say the grammar is not SLR1 and the algorithm fails to produce a parser. There will be conflicting actions means if in the same column there comes a shift and reduce, then it is a conflicting action. Or if it comes two reduce actions in the same column, then it is also conflicting. So in that case, we cannot produce a parser. Then the go-to transitions for data are constructed for all non-terminals. So here action part we constructed for terminal symbols. Now the goto is constructed for non-terminal symbols. Okay. Now goto of II comma capital A equal to ij, then goto of I comma capital A equal to j. That is if you have I0 and on capital E you are going to I3, then you can write state 1 on capital E goes to 3. That is what. Now all entries not defined by rules to entry are made error, and the initial state of parser is the one constructed from set of items containing s dash giving s dot. Okay, so this is how we are constructing an action and go to in passing table. You will understand more when we go to example. So this is an example of action and go to. Here we will write all the states. Okay, in this is a column for writing the states. Here in this action part you will be writing all the terminal symbols. Okay, and in the go to table you will be writing only non-terminal symbols, and don't forget to include dollar here in this action part. Then as we have discussed, we will check each state with each terminal symbol and write whether there is a shift or a reduce. In the case of shift it is represented by S. In the case of reduce it is represented by smaller. And all blank entries are considered as error entries. Now, there are two types of conflicts as we have discussed in shift radius parser itself. So if a state does not know whether it will make a shift operation or reduction, we say that it is a shift reduce conflict. Similarly, if there are two reduction possibilities, it is also reduce conflict. So if the SLR parsing table has a conflict, we say that the grammar is not SLR grammar. So this is how we will check whether a grammar is in SLR or not. Now we will see an example. So this is a set of productions in the grammar. So the first step is to calculate the augmented grammar. Okay. And you have to number these predictions without considering that augmented prediction. First you have to construct an augmented grammar and you have to number these predictions. Then only we can name whether in which by which prediction we can shift or by which prediction we can reduce. Okay, now this is our augmented grammar. I have added an prediction e dash giving e. We have to compute follow for each of the non-terminals. For each non-terminal symbols, compute the follow. Now, the next step is compute the LR0 automation. Okay, so I0 it consists of I e dash giving dot e, and since there was capital E after dot operation, we'll consider E fractions. Since there is a dot operation before T, I have to include T fractions, and since there is a dot before F, I have to include this F fractions. So this became my I0, right? Then I perform go to operation from this I0 and I got I1. How? I0 comma E. Similarly, I will get okay, and by performing this closure and go to, I got LR0 automation with 11 states. Okay, hope you have a clear understanding on how to compute LR automation. Now I have this LR automation. So from this I have to construct the parsing. So let us see how to compute this parsing table from this LR0 automation. Now first consider the state I0. Okay, in this state I0, check for the first condition, that is whether there is any terminal symbol after dot. So when we check, we have two predictions with terminal symbols after dot. Have f giving dot e within brackets. So the symbol bracket comes after dot. So then what you have to do, you have to check on this symbol bracket whether you are going to a particular state. Okay, so I got that this state I4. So what you have to write, state 0 on left parenthesis going to I4. So shift by 4. Similarly, there is ID. So on ID it is going to 5, right? So I will write 0 on ID shift to 5. Okay, this is the, there are no more predictions with a terminal symbol after dot, only these two terminal symbols. Now second is check whether there is a prediction with dot at the end. So there are no prediction with a dot at the end. So this action part is over. Now what is the third one is whether there is the prediction with e dash giving e dot. So this dot e not e dot, so don't have to worry about that. Now we have to see whether there are goto. Okay, so goto is always constructed for non-terminal symbols. So from I0 we have three non-terminal symbols going out, capital E, capital T and capital F. So I0 on E is going to I1, so I will write 0 on capital E 1. Similarly, I0 on capital T going to I2, so I will write 0 on capital T 2. Similarly, I0 on capital F going to I3, so I'll write 0 on capital F 3. Okay, so I0 state is okay. Now we'll go to state 1. So check whether there are any prediction with a terminal symbol after dot. I have this prediction, right? There is E dot plus. So check whether plus is there. Okay, so here plus is there to I6. So what will you write? 1 on plus shift S. So 1 on plus shift to S. Then second condition, there is a dot at the end. Here there is a dot at the end, but this is a third condition, right? When there is a production of the form E dash giving E dot, what you have to write, on dollar we have to write accept, right? So state 1 on dollar we will write accept, since there was the production E dash giving E dot. Dot is at the end, so I state 1 on dollar accept operation. There are no non-terminal symbols going from state 1, so there are no go to. Okay, now I will go to state 2. Now I2, first condition, that is there is a dot after a term before a terminal symbol, and that terminal is going to I7. So you have to write state 2 on star going to state 7. So you'll write 2 on star S7, shift to 7. Then there is the other condition, that is E giving T dot. Okay, that is the dot is at the end. So what you have to do, you have to compute follow of E. Okay, then on follow of T we will get sorry, not T, follow of E. On follow of E, whatever symbols are included, you have to reduce it by this production E giving T. So when you look at this set, E giving T is the third production. I have numbered it as 3. Okay, sorry, I have numbered it as 2. That is why here it is R2. Okay. On I2, follow of E includes plus, right parenthesis and dollar, and it is reduced by E giving T. In my question, I have numbered it as second production. So I write reduced by 2. That is why it is R2, R2, R2 here. Okay, from this there are no non-terminal symbols going out, so there are no go to. Now consider the state 3. When I go to state 3, there are no terminal symbols after dot, but there is a prediction of the form t giving f dot, right? Dot is at the end. So what you have to do? Compute follow of t. Okay. Now the follow of t will consist of plus, star, right parenthesis, and dollar. After taking follow of t, you have to write on that terminals what? By this prediction. Now it's t giving f, I have numbered it as prediction 6. Okay, so I will write R6, 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 sorry, I3. So I have written prediction 4, so reduced by 4. Now R4, 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 R4. Okay, so that is why it is written R4 here. Similarly, you have to do still state level. Okay, so this is a passing table of expression grammar once you complete 11. So hope you have understood this tutorial. Kindly go through it. So thanks for watching.